we're going to start with me telling you that I made a mistake and was wrong. And that's not going to happen very often, so be used to it. But when I was discussing the precedence, I made a mistake because I was focusing on the precedence of a certain subset of operators, and I said they're right to left. But actually, in Java, afterwards I was like, that doesn't sound right. Let me look this up. And lo and behold, different operators have different precedence. Some of them are left to right, some of them are right to left. So it's nice and confusing. But I wanted to correct that point for you. Now, the saving grace is that most of the arithmetic operators, like plus, minus, multiply, divide, those are actually the way that we read them from left to right. So I've corrected the slides, and I wanted to make sure I let you know. Sorry, I'm human, and sometimes I mess things up. So hopefully you can forgive me for that. What I would like to do now, though, is go ahead. Oh, good, it's showing up. I'm going to go ahead and just do a quick, very brief review because I also got tired of some of the slides that we were using, so I decided to build some new ones. And I want to review the arithmetic operators before we get into this new stuff for today. But before I do that, does anybody have any questions they would like to pose at this moment that they think everyone would get value from me answering in front of 600 people? No? Okay. So, yeah, I wasn't trying to put you on the spot. You can still ask questions. I mean, it's okay. So basically, I just wanted to go through an example we had before and go into a little bit more detail. So we talked about how we have this outer shell, this boilerplate code, where we create a class and we also create the main method. And we are going to get into the details of what a class is and what makes it public and what static is. We're going to get into all of those things, but we're not there yet. If you want to understand it, I'm happy to explain these details to you, and I'm going to add little points on the slides from now on that say, if you're curious, and if you see a box that says, if you're curious, that means I'm not testing you on this yet, and this is just for the people who really want to know the little details, but you don't have to worry about knowing the little details right away. Everybody get the idea? Okay, so the box says, if you're curious, that's what it means. So before we were talking about arithmetic operators, remember that we have variables and they have names, and those names can be anything that's valid, and there's a couple of rules that we talked about. In this case, we have variables of type int, which is short for integer, and we have 4 of them: monkeys, trees, per monkey, and per tree. We also established a couple more variables: start, ground, rotten, num, and good, where start is how many bananas we start with, ground represents how many bananas are on the ground, rotten represents how many rotten bananas there are, num is like the total number, and then good is how many bananas are good, those that are not rotten. And then we used some arithmetic to make some calculations. So the first operator we looked at was plus. So if we want to know the total number of bananas that are not in trees, there are the number that we started with plus the number that are on the ground. That's that plus sign, right? And I've kind of highlighted in green the different operators. If we then wanted to add to that the number of bananas that are in the trees, we would reset num to be equal to itself plus the number of trees times the number of bananas per tree. This is an example of precedence that we're going to take a look at in more detail in just a minute. Then we set the number of good bananas equal to the total number minus the number of rotten. And then to determine how many bananas there are for every monkey, we divide the number of good bananas by the number of monkeys. And there's 2 ways we can calculate this. These are numerically equivalent, right? And then we print out the values at the end. So this right here is our first example of precedence. Just like in math, multiply is going to take precedence over plus. So in this case, we're going to multiply and then we're going to add afterwards, because the multiplication symbol has higher precedence, so we're going to multiply first. This is another example. In this case, what has precedence? The parentheses. The parentheses have precedence, and because the parentheses have precedence, we're going to do the subtraction inside the parentheses, and then we're going to do the division. Another thing that I did point out that a lot of people were asking me about last time is operators are not just for numbers. Here we have strings. We have values with letters and numbers in them, and we can actually add those together too. And when we add two strings together, we're basically just putting them together. We're concatenating them. We put one and then we put the second one. And so when we concatenate these together, we get one big long string with all the different numbers in it. For the precedence of the arithmetic operators, I'm going to put these slides up. I haven't put the newest version up, but I'm going to. We have, obviously, parentheses. So a lot of this is going to match what you've seen in mathematics. Parentheses, we apply negatives. Then we apply multiplication, division, modulo, addition, and subtraction. Multiply, divide, and modulo, and we haven't talked about modulo. We'll get to that in just a second. Those all have the same precedence, which is higher than add and subtract. And add and subtract have the same precedence. And all of those are lower than applying a negative to a number. And all of those are lower than applying something in parentheses. Straightforward so far? Okay, so modulo. Modulo is a fancy computer term that means get the remainder. So when you do straight division on integers, multiplication, addition, subtraction are pretty straightforward. But when we do a division, and we use integers for division in computers, we're going to get a truncated value. That means we're going to get everything before the decimal. If we do 45 divided by 7, we're going to get 6. That's going to be the result. We're not going to get 6 I don't know what 3/7 is, 6 and change. We're going to get exactly 6. The way that we get the remainder for that is we use the modulo operator. And I just seen that there's a typo. That's what happens when I write slides really late at night. This second one should be the modulo symbol. Let's try this again. Okay, so it should be 45 modulo 7 is going to give us a result that is 3. Right. So that'll give us 3. Everybody straightforward with that? So you will probably see the modulo operator a lot over time, so it's important to understand how it works. Yes?
Not a big deal, but I think 3 plus 4 times 4 is 28.
Yeah.
Oh, yeah. I can't add. Look, I don't know what to tell you. I'm going to fix it later. Okay? I'll fix it later. It's been a long week. That's why I have a computer and a calculator, because I can't actually add those numbers myself. Okay, anybody? Yes?
So back on the other slide, when you said that for dividing 45 divided by 7, you said it would give us 6.
Yes. What's that?
Why would it give us the actual 6? Why would it give us 6?
Well, it gives you 6 because it gives you the division without the remainder. So if you actually do this division, it'll give you 6 point something, right? But when you do division with integers in computers, they will only give you integers back. They won't give you, if you want to get a radix-based number, in other words, a number with a decimal in it, then you have to use a different set of operations. You have to use you have to use a different type, which we're going to get to in a few minutes, called a floating point number. There are trade-offs, though. Floating point numbers have some drawbacks that integers don't. Integers are like the native type of number in a computer, so we usually use them if we can get away with it. Does that answer your question for the moment? And we're going to go into more detail about radix-based numbers soon, okay? Okay, anyone else?
What is prec is what?
What's that?
Prec?
Oh, precedent, that stands for precedence. Sorry.
Okay. Oh.
I just couldn't fit it on the slide otherwise. Yeah, that's just precedence, meaning like parentheses have the highest precedence, and subtraction and addition have the lowest.
Negative numbers have 2.
Yeah, so the precedence of the negative symbol as applied to a number comes just below parentheses. So you always apply parentheses first, but then if there's a negative symbol, you would apply that
Okay,
afterwards.
you're right.
Does that make sense
Yeah.
now? So negative is different from subtraction.
Yeah.
It's an important distinction. Cool? Okay.
Yeah.
Anyone else? Yes?
Do you always round down for the E? Does it always round down there?
Yeah, that's a good question. The question was, does the division always round down? And the answer is yes. It is not a rounding operation, it is a truncation. When we say truncate, we mean we cut it off, right? So basically, whatever, it could be 6.9, and it's going to become 6. Does that make sense? Okay. But you can get the remainder using the modulus, right? Using the modulo. Okay, anyone else? Yes?
White space doesn't matter. How do you tell the computer is negative and not correct?
Parentheses.
That's a good question. The question was, if white space doesn't matter, how do you tell the computer it's a minus and not, I'm sorry, it's a negative and not a minus? And the answer to that is the computer figures it out by context usually. So if there are numbers on both sides, it will interpret that as a minus. If there is only a number on one side, it will interpret that as a negative. Let's see, does that answer your question? Okay. Yes?
So if we divide a double by int, the type equals
Oh, that's a good question. The question is, if we divide a double by an int, what's the result? And the result is definitely that it depends on the language, first of all. Usually, pretty sure, usually in C family languages, and I'm fairly certain Java is like this too, if you divide a double by an int, you get a double as the result. But it's definitely, it varies highly by languages, so you've got to be careful when you do that. Usually what you do is you tell the computer explicitly what type of result you want, just to be safe. Does that make sense? Okay. Anyone else? All right, so let's talk about input-output. And I was talking to a couple of you just before class started, and in hindsight, I really should have covered this 2 days ago. So we're going to cover it now, but a lot of you have been struggling with it. I just want to go over the formalities of how you use the scanner and the system input and the system output and stuff like that. So the first piece of the puzzle right here is this import java.util.scanner line. And the import lines, basically what import does is it says to the Java compiler, hey, I want to pull in a snippet of code, something I can execute from another source. It means it's not, the way to do this operation is not actually built into my source file. I want to get it from somewhere else. And when we call an import statement, that's what we're doing. In this case, what we call a package, the package is java.util, and the thing we want to bring in is the scanner. So we're going to see this repeated over and over and over again. This is a pattern you're going to get very used to. The idea is that we're going to bring in an outside piece of code, and if you've taken another language, you've seen things like this in other languages too. But we're going to bring in an outside piece of code into our program so that we can use it. Right there. Then we, of course, have our boilerplate where we have, by the way, when we say boilerplate code, that just means code we have to do all the time and we kind of like copy paste it, right? Then we bring in our structure for the class and the main function, and then we can start writing code. The way that you use a scanner is that we have to say, hey, I want to create a new scanner, and I want it to read from the system's input. That's what this line means. System.in means the system's input system. System.out means the system's output system. Make sense so far? Yes?
Let's say you don't want to name your scanner, but you want to name it you want to name your scanner pizza instead. So scanner pizza equals new scanner system.
That's right, yes. So the question was, what if I didn't want to call my scanner lowercase scanner? What if I wanted to call it pizza or Bob's your uncle or whatever? Then I could totally do that, right? I could have scanner Bob's your uncle equals new scanner. I can call the scanner whatever I like, right? This is just like a default name I'm using. That's a good question, thank you. All right, so we got to create this scanner, and we say I want to get the input from the system's input. And there are other things you can get input from, but we can worry about those later. Just be aware that that's why we put this in. Then we're going to make a place where we want to store the response, which is what we call a string. Yes, sir?
Are you creating the class on the left side and then on the right side is the method to the class? Is that what that is?
So
Like, new
the
scanner
question
thing?
is, I'm going to rephrase your question just a little bit. The question is, what are we doing here exactly? And the answer is well, I'm rephrasing because I don't want to use some confusing words. That on the left side, the first part is you're telling it what type, and the second part is you're telling it the variable name. So you're saying, I want to create a variable called scanner, called lowercase scanner. I really should have used a different name. Called lowercase scanner, and the type of that is the scanner type that I pulled in before. Does that part make sense so far?
Yeah.
On the right side, I'm saying I need a new one, Like it doesn't already exist yet. I need a new one, and I needed to pull from the system's input. And we're going to get into a lot of detail about how that new word works later, but for now, it's good enough to know that what we're doing is we're saying, I need a new one of these scanners, and it should be pulling from the system's input. So does that answer your question sufficiently? Okay. All right. So then we have what we call string response, right? So this is another data type. We talked a little bit about types last time. And this type is a string because we're going to get whatever the person types. And then we print out to the screen what the monkey's saying. And I'm not going to read that. I'm sorry to disappoint you. But if anybody wants to do like a monkey impression and wants to be the person who comes up here and screams these things for me, you can do that. So we print this out to the screen. And the output, the result, is that it says, okay, maybe I will.
Oh my God, yeah.
I'll be here until 5:10. And then the system says, how are we going to respond? So there's an important distinction to make here. So we've talked about the input. We talked a little bit about the output. This says system.out.println. System.out means go to the system's output subsystem. And println means print a line of text and then start a new line. So print line. Write the text to the screen and then start a new line. If you just say system.out.print, it will not go to a new line. It'll stop right there on the existing line. So if I call this line, it's going to print this to the screen, and then if I ask the scanner, if I say, hey scanner, give me some information. This is a method. Next is a method, right? So we're saying, hey scanner that I created, give me the next thing that somebody types. Give me the next string in this case. Then what's going to happen is it's going to read whatever we type into response. Right? So maybe I type this, and it shows up like that. And then we can turn around and print out the result of that. That's what this system.out line means. Now, you see all these funny symbols in here, and this is another thing that people were asking me about last time. If you want to print a double quote in Java, then you have to use what we call an escape sequence, which means we do a backslash, which tells the computer, hey, this is not the end of what I was typing, I'm just doing a special symbol. In this case, we do backslash, double quote, and that makes it put a double quote symbol in there. If we want to do a new line, there's another version of that, which is just /n. Some of the other ones we talked about briefly were /t for tab. Can't think of any others. /r for carriage return, and there's a few others. So there's a whole list of them. If you're interested in taking a look at them, they're all in the Java API documentation, which we're going to also take a look at today. So just be aware of that. There's lots of information out there. But these are a couple of really common examples. Slash quote and /n are really common whenever we want to print these special symbols. And so that's going to be the result. Okay, does anybody have any questions up to this point? Yes?
When you were doing the response scanner next line, why is there a set of
Why is there a what?
a set of
Oh, the question was, on line 12, response equals scanner next. Why is there a set of parentheses? That's an excellent question. And the answer is, anytime in Java, anytime we call a method, anytime we're telling some object to do something, then we have to have parentheses so that Java knows that it's a method. So if you look really closely on the system.out.println lines, you're also seeing that, right? There happens to be stuff in the middle in this case, but you always have to have that. You always have to have those open and closed parentheses because they're what Java uses to know if you're giving an instruction to an object. If you're telling, in this case, we created that scanner, right? We're telling the scanner to give us the next object, but it won't know what we're talking about if we don't have the parentheses. Does that answer your question? Okay. Anyone? Yes?
Where exactly